Hello everybody, this is Group G8 from Vishwakarma Institute of Technology. Today we will be learning about working of interrupt-driven I/O. This is my team. And on today's agenda we have introduction, basic operations involved, interrupt processing from CPU viewpoint, interrupt priority, advantages, disadvantages and examples. So let us start with the introduction.
Starting with what we mean by an interrupt, it is a signal emitted by hardware or software when a process or an event needs immediate attention. Now, interrupt-driven I/O is an interrupt-controlled data transfer method. It means that data transfer process is initiated by an interrupt. I/O module signals the CPU when data to be transferred is ready with the module. Hence, CPU doesn't have to wait for the required data. Moving on to basic operations involved in the process. When CPU needs some information, it generates a read command. I/O module fetches required data from the concerned peripheral. Meanwhile, CPU does some other work. When the module is all set, it interrupts the CPU, then CPU requests data and I/O module transfers it.
Moving towards interrupt processing. First, the device issues the interrupt to CPU. Then the CPU finishes the execution of the current instruction. Then CPU tests for pending interrupt request. If there is one, it sends an acknowledgement to the device which removes its interrupt signal. CPU saves the program status word onto control stack. CPU loads the location of the interrupt handler into the PC register. It saves the content of all the register from the control stack into memory. Then finds out the cause of interrupt or interrupt type or invokes the appropriate routine. Then restores the save register from the stack, and then restore the PC to dispatch the original process.
Interrupt processing from CPU viewpoint. From CPU's viewpoint, interrupt processing starts with CPU issuing a read command. After that, it goes to some other work while I/O module fetches the data. At the end of every execution cycle, it checks whether an interrupt has occurred or not. If interrupted, it saves its work done, processes the interrupt, fetches the data and stores it. After that, it goes back to its earlier position. Interrupt priority determines order in which various interrupts will be served, also decides which interrupts can interrupt while other is being addressed. Higher priority interrupts may request service when low priority one is dealt with.
Now to summarize. First, CPU issues a read command to I/O module. Then there is a checking for interrupt. Then once the interrupt is confirmed, read status of I/O module. Check status for error conditions, read word from I/O module, then write word into memory and then check if it's done. Once it's done, either perform the next instruction or repeat the set of instructions.
Advantages of interrupt-driven I/O includes polling time of CPU is saved. This is possible because it enables more efficient use of CPU resources and faster response time. It is more efficient than programmed I/O because it is more scalable and flexible method for handling I/O operations. This results in faster response times and simplifies programming, and it is faster than polling. While interrupt-driven I/O provides several advantages, it also has some disadvantages that should be considered. These include the cost is comparatively more because interrupt-driven I/O requires additional hardware and software components to manage the interrupt and handle the I/O request. Also, it is difficult to get various parts to work well together. Moreover, it is tricky to implement when working with low-level lines. Here are some examples of interrupt structures, and they are Intel 82C59A interrupt controller and Intel 82C55A programmable peripheral interface. Now we conclude with our presentation. Thank you.